explanation of vector. While solving the problems on Coulomb's law application, we first must know about how to resolve the vector. So today we will find how to resolve the vector. So we have taken 4 quadrants and one vector in it. So we have to resolve this vector. We resolve this vector into 2 components. This vector makes an angle theta 1 to this quadrant. This is theta 1. This is, so we have taken either side of that vector. So angle is either side of this vector. So we also take angle on either side of this resultant or resolved vector, and we have taken a cos theta component on adjacent to the angle, and remaining component is a sin theta. We have taken another component b in quadrant number 2, and we have to resolve this vector b into 2 components. It makes angle theta 2 in quadrant number 2. Similarly, we have to take on either side of the angle. And adjacent side component is cos theta component. So b cos theta 2, and remaining is b sin theta 2. We have taken another vector, vector c, in third quadrant, and we have to resolve this vector into 2 components. It makes angle theta 3 in this quadrant, and take the angle on either side of the vector. The component adjacent to the angle is c cos theta 3, and another component is c sin theta 3. We have taken another component in vector, that is vector number 4, or in fourth quadrant, that is vector d. It makes angle theta 4 in quadrant 4, and we have to resolve this vector into 2 components. Take the angle on either side of the vector, that is theta 4, and this adjacent component is d cos theta 4, and the remaining component is d sin theta 4. So in this way we can resolve the vector. We have to take angle on either side of this angle, okay, and the adjacent component of the angle is cos theta component, and the remaining component is a sin theta component. Okay, so in this way we can resolve the vector in different quadrant. Okay, example number 1. Find the net force on the charge q due to charge q1 and q2. We have two charges q1 and q2, and we have to find the force, net force on the charge q due to charge Q1 and Q2. The distance between this center and the Q1 is d by 2, and this center and the Q2 is d by 2, and the whole distance is Q1 to Q2 is d, and the from center to charge Q is Z. This solution. This is your charge plus Q1, this is your charge plus Q2. The charge Q is located this is charge Q or Q3. We can call it as Q3. From the center, its distance is d by 2, and from the center, the distance of charge Q3 is Z. First, we find the net force on the charge Q3 due to charge Q1. We join these two charges, and both charges have same polarity, positive, therefore they repel each other, and the direction of the charge or direction of the force is away from the charge. It makes angle. So this vector component is, or this force component is resolved into two components. This is angle theta, this is F1 cos theta, and this is F1 sin theta. And this is the z square d square by 4 by applying the Pythagoras law. This is d by 2 or this is z, therefore this hypotenuse is under root z square plus d square by 4. Similarly, we find the force on charge Q3 due to charge Q2. They both have same polarity, that's why they repel, and the direction of the force is away from the charge. This force component is resolved into two components. This is angle. Okay, we have taken either side angle on the vector or force component. This is F2 cos theta, this is F1, this is F2 sin theta. So this is also z square plus d square by 4 according to triangle law. So F1 is K, this Q1 Q3 upon the distance square, that is under root z square plus d square by 4 square, that is z square plus d square by 4. Okay, square and square root get cancelled. F2 is Q2 Q3 K Q2 Q3 upon, this is square of the, this is z square plus d square by 4. So we got F1 and F2. This angle is theta, also therefore this is also theta. So we have to find, this is also theta, so we have to find sin theta. Sin theta is the opposite side upon hypotenuse. Therefore, opposite side of the theta is d by 2. d by 2 upon hypotenuse is under root z square plus d square by 4 force magnitude on x-axis. So this is f2 sin theta and f1 sin theta on x-axis, and this f2 cos theta and f1 cos theta on y-axis. So we have to find the force magnitude on x-axis, but the both directions are in opposite direction. F1 sin theta in right hand direction, therefore it is positive, and f2 sin theta in a left hand direction, therefore its sign is negative. It is f1 minus f2 sin theta. It is force magnitude on x-axis. This is equation number 1. Similarly, force magnitude on y-axis. On y-axis, both are in upward direction, f2 cos theta and f1 cos theta. Therefore, they both are positive. f1 cos theta, that is f1 plus f2 common cos theta. This is put the values of f1 and f2 in equation first and second. This fx is equal to, what is f1? It is k q1 q3 upon z square plus d square by 4 minus, what is f2? f2 is k q2 q3 upon z square plus d square by 4 into sin theta, and sin theta is equal to d by 2 upon under root z square plus d square by 4. So we can put this value here. This fx is equal to, it is common in this two term, k, it is k q3 upon, in denominator z square plus d square by 4 common. So we have taken this common, remaining q1 minus q2 into sin theta. We have to put the value of sin theta here, d by 2 upon under root z square plus d square by 4. So this is fx. And what is the cos theta? Cos theta is the adjacent side upon hypotenuse, that is adjacent side is z upon hypotenuse is the under root z square plus d square by 4. So we put the value in equation number 2. It is fy is equal to k q1 q3 upon z square plus d square by 4 plus, it is f2 k q3 q2 upon z square plus d square by 4. It is cos theta. Cos theta is z upon under root z square plus d square by 4. Okay. In short, we can write it as common terms are k q3 upon z square plus d square by 4. What is remaining? q1 plus q2 into z upon under root z square plus d square by 4. This is equation number 3 and this is equation number 4. By adding these two equations, we get resultant force or net force on this charge. Add two vectors fx and fy, we will get f. Resultant that is f bar is equal to fx I cap plus fy j cap. This is vector, so we can take I cap and j cap. Okay, fx along the x coordinate and fy along the y coordinate. Therefore, it is fx I cap plus fy j cap. This f bar is equal to k q3 upon z square plus d square by 4. q1 minus q2 upon d by 2 under root z square plus d square by 4 I cap plus what is fy? Fy is k q3 upon z square plus d square by 4 q1 plus q2 z upon under root z square plus d square by 4 j cap. So this is the resultant force or the net force on this charge due to two charges q1 and q2. So in this way we can find the net force or resultant force. Second example, example number 2, find the net force on the charge q, that is fq we have two charges q and q, and due to this two charge we have to find the net force on the charge small q. Distance between the center and the charge q is d by 2 and d by 2, and distance of charge small q to center is z. Solution. Again we draw this system of charges q, q, this is q, this distance is d by 2, again this is d by 2, this is z. So we have to find the force on charge q due to this charge q. Join this charge. both charges are positive, therefore they repel each other and the direction of the force is away from the charge. Again, this force is resolved into two components. This is theta, F1 cos theta, because this is adjacent to the angle theta, and this is F1 sin theta. Due to the charge, second charge Q, the net force on the small charge Q is, both charges are positive, therefore they repel each other, and the direction of force is the opposite from the charge, or it is away from the charge. Again, this is making angle theta, and it is resolved into two components. This is also angle theta, and the adjacent to the angle theta is F2 cos theta component, and this is F2 sin theta component. This is F2 cos theta. This distance is d by 2, and this distance is z, therefore it is under root z square plus d square by 4 according to triangle law. And again, this is z, this is d by 2, therefore this is under root z square plus d square by 4 according to triangle law. Okay, this is theta, and this is also theta. Angles are opposite, therefore this is theta and theta. So cos theta is equal to, cos theta is the adjacent side upon hypotenuse, that is z is the opposite side upon hypotenuse is under root z square plus d square by 4. Force F1 due to these two charges Q, this is K upon under root z square plus d square by 4 square. This becomes K Q upon z square plus d square by 4. Similarly, F2 is equal to K Q upon z square plus d square by 4. Here F1 and F2 are same. Here F1 and F2 are the same, but the direction of the force on x-axis is opposite, therefore these two forces cancel each other. It is F1 sin theta and F2 sin theta cancels each other. F sin theta are opposite direction, so cancel each other. Only cos terms are remaining here, and both cos terms are in upward direction, therefore both are positive. It is FQ F1 cos theta plus F2 cos theta. F1 is equal to F2 is equal to Therefore, we can write it as FQ is equal to twice F cos theta. And what is the value of F is K Q upon Z square plus T square by 4. And what is the value of cos theta? Cos theta is Z upon under root Z square plus T square by 4. This is FQ is equal to twice KQQ upon Z square plus T square by 4 into Z upon under root Z square plus T square by 4. We can write it as twice KQQ Z upon this Z square plus T square by 4 into under root Z square plus T square by 4 is equal to Z square plus T square by 4 raised to 3 by 2. So this example number 3. Find the net force on the charge minus Q. So we have given Q minus both Q and plus Q charges. Due to this, we have to find the charge on minus Q. The distance between Q and the center is d by 2, and the distance between Q and center is d by 2, and the distance between minus Q charge and the center is Z. We have to find the force on the charge minus Q due to other two charges. The solution. Again, we draw this system Q. This is minus Q d by 2 Z. This is 1, this is 2. We consider this charges. This is plus, this is minus. Therefore, they attract each other, and the direction of the force is towards the charge. Therefore, this direction is towards, that is inside. It makes an angle theta. The both charges are opposite, therefore they attract, and the direction is towards the charge. This is also theta. F1 cos theta, and another one is F1 sin theta. We have to find the force on the charge minus Q due to the charge Q. Both have opposite polarity, that's why they attract each other, and the direction is towards the charge. This is theta. Therefore, this is F2 cos theta, and this is F2 sin theta. This is Q, this is Q, this is F1 cos theta, F1, F both are at downward direction, and F2 sin theta, F1 sin theta both are in opposite direction. F1 is equal to K Q upon this distance is under root Z square plus D square by 4. So we can write it as kqq upon z square plus d square by 4. F2 is equal to, that is kqq upon, this is d by 2, this is z, therefore this is under root z square plus d square by 4, its square is equal to kqq upon z square plus d square by 4. So F1 is equal to F2 is equal to F1 and F2 is equal to, both are same. Okay, and the sign component are in opposite direction, therefore they cancel each other. So F1 sin theta and F2 sin theta cancels each other. The Fx is cancel. So only Fy is remaining, and the cos component is in a downward direction, therefore it has a negative sign. It is Fy, it is Fq is equal to F1 cos theta and F2 cos theta. F1 cos theta plus F2 cos theta, and they both are in a downward direction, so they have a negative sign. Fq is equal to F cos theta plus F cos theta. Fq is equal to minus twice F cos theta. Notice the value of F. Fq is equal to minus twice k q upon z square plus d square by 4, and the value of cos theta is, okay, here cos theta is equal to adjacent upon hypotenuse. The z is adjacent side and hypotenuse is under root z square plus d square by 4. So we can put the value of cos theta here, z upon under root z square plus d square by 4. So this is the force on the charge minus q due to these two charges. It is minus 2zk q upon this multiplication becomes z square plus d square by 4 raised to 3 by 2. Okay, this is the final or net force on the charge. Z square plus d square by 4. So we can write it as kqq upon z square plus d square by 4. F2 is equal to, that is kqq upon, this is d by 2, this is z, therefore this is under root z square plus d square by 4, its square is equal to kqq upon z square plus d square by 4. So F1 is equal to F2 is equal to F1 and F2 is equal to, both are same. Okay, and the sign component are in opposite direction, therefore they cancel each other. So F1 sin theta and F2 sin theta cancels each other. The Fx is cancel. So only Fy is remaining, and the cos component is in a downward direction, therefore it has a negative sign. It is Fy, it is Fq is equal to F1 cos theta and F2 cos theta. F1 cos theta plus F2 cos theta, and they both are in a downward direction. So they have a negative sign. FQ is equal to F cos theta plus F cos theta. FQ is equal to minus twice F cos theta. Notice the value of F. FQ is equal to minus twice K Q upon Z square plus T square by 4. And the value of cos theta is, okay, here cos theta is equal to adjacent upon hypotenuse. The Z is adjacent side and hypotenuse is under root Z square plus T square by 4. So we can put the value of cos theta here. Z upon under root Z square plus D square by 4. So this is the force on the charge minus Q due to these two charges. It is minus 2ZK Q upon this multiplication becomes Z square plus D square by 4 raised to 3 by 2. Okay, this is the final or net force on the charge. Example number 4. Find the net force on the Q so we have charges Q minus Q and this is small q. Distance is Z and this distance is D by 2 and D by 2. We have to find the net force on the charge small q due to this two charges plus q and minus q. Solution is, again we draw this diagram. This is q, this is minus q. This is q. We have to find the force on the charge q due to this charge q. The both charge are same, therefore they repel each other and the direction of the force is away from the charge. This is Z square plus D square by 4. Because of this is D by 2 and this is Z according to triangle law. This force is to resolve into two component. This make an angle theta. Therefore this is theta. This is theta, therefore this is F1 cos theta and another one is F1 sin theta. So we have to find the force on the charge q due to this minus q charge. Both charges are opposite, that's why they attract each other. and the direction is towards the charge. This is an angle theta, therefore this angle is theta. This is F2 sin theta and this is F2 cos theta. It is sin theta is equal to opposite side upon hypotenuse. Therefore, this is d by 2 upon hypotenuse is under root z square plus d square by 4. This F1 is equal to this, both have opposite direction and these are in same direction. That is F1 K Q Q upon distance square is z square plus d square by 4. Similarly, F2 is equal to K Q Q upon z square plus d square by 4. Both have same magnitude but they are in opposite direction. On y-axis only x-axis term is remaining, that is F1 sin theta plus F2 sin theta, and here F1 and F2 are equal, therefore F is equal to F1 is equal to F2. So F is equal to FQ is equal to F twice F sin theta. Therefore twice, what is the value of force? That is K Q Q upon z square plus d square by 4 into sin theta. What is the value of sin theta? Is d by 2 upon under root z square plus d square by 4. It is I cap. It is only on the x-axis, y component is cancelled. This is I cap. This is the net force on the charge Q due to plus Q and minus Q charges. Of Q is 2 K Q Q d by 2 upon the multiplication of these two terms is z square plus d square by 4 raised to 3 by 2 I cap. Okay, this is the net force on the charge Q. One note: while finding the resultant of the vector for vector or force, we first know how to find the resultant vector or the force. This is useful in solving the problems application oriented in Coulomb's law or in magnetostatics. So we have two vectors F1 bar and F2 bar, and we have to find the resultant vector. Two vectors make an angle this theta. We have to find F bar. So there is one formula for finding the resultant vector F bar, that is, this is an angle theta. So theta is the angle between two vectors F1 bar and F2 bar. While solving examples, the resultant is f bar is equal to under root mod f1 square plus mod f2 square plus twice mod f1 into mod f2 cos theta. This is the formula for finding the resultant vector among two vectors. When theta is 0 degree, when the angle, this angle is a 0 degree, then cos 0 is 1. Then the resultant vector f bar becomes f1 bar plus f2 bar plus twice f1 f2, and this cos theta is 1. So when the forces are same, that is f1 is equal to f2 is equal to f, then we can write it as f1 square plus f2 square. Okay, we can write it as f1 plus f2 square, that is square and square root get cancelled. F is equal to f1 plus f2 when theta is 0 degree. Angle between two vectors is 0 degree, then f is equal to f1 plus f2. When theta is 60 degree, the angle between two vectors is 60 degree, then cos 60 is equal to 1 by 2. So f is equal to under root f1 square plus f2 square plus twice f1 f2 into 1 by 2. Okay. When angles or forces are same, f1 square plus f2 square, this 2 get cancelled. F is, when f1 is equal to f2 is equal to f, so both are equal to same, so we can write f1 square plus f1 square plus this f1 into f1 f1 square, so thrice under root 3 f1 square, so root 3, and this square and square root get cancelled, root 3 f1. So when angle is 60 degree, the resultant is root 3 f1. When theta is 90 degree, then cos 90 is, what is cos 90? 0. So we can write it as f1 square plus f2 square plus 0. So f is equal to, when both the forces are same, therefore f1 square plus f1 square, it is twice f1 square, therefore root 2. Okay, this is under root 2 f1 square, that is root 2 f1, where theta is 19 degree. And when the similarly theta is 180 or 120, f is equal to f1 and theta is 180. When theta is 180 degree, f is equal to f1. Example, consider three identical charges are placed at the corners. Here, three identical charges are placed at the corners of an equilateral triangle of side A. Side is A as shown in the figure, and find the net force on any one of charges due to other charges. So So we have an equilateral triangle. So triangle is equilateral and the charges are on at the corners of an equilateral triangle Q, Q and Q. Triangle is equilateral, therefore the angle is 60 degree, this is 60 degree and this is 60 degree. And the side of the equilateral triangle is A, therefore all sides are same, therefore this is A. And we have to find the force on any one charge due to other two charges. Okay, so we have taken this charge, so we find the charge on this charge due to other two charges. This is 1, this is 2. Okay, so both charges have positive, therefore they repel each other and the direction is away from the charge. Again these two charges are positive and the direction is away from the charge. This is 60 degrees, so because of this again opposite angle is 60 degree. It is F1 is equal to K Q and this is Q, therefore this is Q square upon A square. Similarly F2 is K Q square upon A square. Both charges are same, both forces are same, or charges, all charges are same when theta is or angle is 60 degree, then and the forces are same, so we can write as F is equal to, or resultant is equal to, F is equal to under root 3 into F1, that is F is equal to root 3 into the force is K Q square upon A square. Okay, this is the net force on any one charge due to other two charges. Example number 2. Consider a 4 identical point charges are kept at the corners of a square of side A. Find the net force on any one charge due to others. Okay, we have to find the net force on any one charge due to other three charges. The side of this square is A and the charges are kept at the corners of the square. So we have to find the force, net force on any one charge due to other charges. Angle is 90 because it is square. So we find the net force on this charge due to other three charges. Okay, we draw again this. Okay, this is Q, 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 and this is 90 degree. Charge 1, 2, 3. This is 4. Okay, we find the net force on the charge number 4. Okay, so because of these two charges Q and Q, both repel, both have same polarity, and that's why they repel and direction is away, and the angle between them becomes 90 degree. So when angle or theta is 90 degree, then the formula for force is root 2 upon root 2 into F. Here F1 is K Q square upon A square and F3 due to third number charge K q square upon a square. Due to second charge, we join this 2 and this distance is both charges are positive, that's why they repel and direction is away from the charge. Therefore this direction is root, or this distance is root 2a, because this is a, therefore this is hypotenuse and root 2a. Okay, so f2 is equal to k q square upon root 2 a square. F2 is equal to k q square upon, when theta is 90 degree, f13 is root 2 into f. So f q is equal to f13 plus f2. That is f13 is root 2 f plus f2. It is root 2. What is the value of f? Is k q square upon a square plus f2 is k q square upon twice a square. It is fq. This is the net force on any one charge due to other three charges. This is the value of net force.